Welcome, everyone. Welcome, Ulf. Welcome, Eric. Thanks for joining us today. The topic for the conversation today is design. Design can be a kind of a tricky topic because it can mean a lot of different things to a lot of different people. So I thought a good place to start would just be to talk about what design means to both of you. Ulf, you want to kick us off? What do you talk about when you're talking about design?
Okay, so I will say that in my career, partly because I ended up working as sort of an architect in a very large company. Ericsson at the time was about 100,000 employees. We were a small project with about 200 people, 200 designers. One of the most important things that I discovered there was the social dynamics, especially around a large project. I mean, Fred Brooks discovered it many, many years before me, but tend to drive many design challenges. And very often it wasn't so much sort of the technical aspects of building complex systems, which is hard in itself. But in many cases, what trips people up is how the entire organization works. And part of it, I think, is that when you're in an organization, and this is even in a medium-sized company, you have people specializing in different things and basically speak different languages, at least in the sense that what kind of metaphors they use, what their frame of reference is. And one thing we found with Erlang when we were discussing why it worked so well in the telecoms realm, which perhaps is not too surprising because that's what it was designed for, was that the mental models in the language and the architecture actually fit well with how the domain experts wanted to view the world and view the problems. So we could have sensible discussions with the product managers, with the customer representatives, customers, and other architects, the people who actually had sort of the vast experience of what was needed in the domain, could actually understand what we were talking about when we were talking implementation. I saw this break down in some other big projects that were using other types of technology like C++ and UML. We saw this huge disconnect between the seasoned experts who knew the domain but didn't know the language, and the programmers who were expert programmers but really didn't understand the domain. And this could really have disastrous results. And what I found when talking to a lot of non-Erlang programmers who were involved in the project was that they felt that they could actually understand what we were doing and what we were talking about. And I think that is hugely important. And of course, if you're in a different domain, you would have to evaluate whether the mental model that Erlang or Elixir gives you is actually a good fit. But anyway, so that I think is one. There are a lot of other aspects of that, but I think I'll leave it at that for now.
Cool, thank you. Eric, what do you think about when you're thinking about design of an application or a library or something? What does that mean to you?
Yeah, so code design, it's a very broad subject. So it can be anything up from the higher level social aspects that you're talking about, and I think really down to the smaller details like the formatting and the syntax of the language, and like Ulf was saying, the language can kind of help you formulate the problem in your domain. So I think one of the reasons that that Erlang and Elixir are strong in this area are because they're kind of no fuss details. They're kind of no fuss languages. If you compare to C++, there's a lot of other things that you need to focus on other than just focusing on the problem, like memory management, for example. And I think another reason is that the way that humans think, we think about how different parts of the systems need to communicate with each other, and we have messages there, and we kind of want to group things together, and those are the processes. So it kind of helps the mental model. And I think even the smaller, and I think even when you look at the smaller details, I think it helps more when you look at functional programming languages, because rather than thinking about for loops, for example, we would like to think about the higher order functions instead of doing the process of thinking about how I need to step through this list and how I need to transform this list. We just write the code to transform the list.
Mm-hmm. Cool. Yeah, great. I also want to remind all of the attendees, if you have questions at any point for either Ulf or Eric, you can ask your questions in the Q&A section on the Wova web app. So that's where we'll be looking for questions that folks have. If any question is particularly relevant to what we're talking about, maybe we'll work them in. Otherwise, we might do some at the end as well. Great. So that's great, great input, both from Ulf and Eric. And both of you did sort of mention quite a bit about the language and how that helps to shape design. And, you know, one of the reasons that we wanted to have both of you here is because we have someone with a lot of Erlang experience, maybe among the most Erlang experience out there. And then also one of the people with probably the most Elixir experience as the second core team member in Eric. So how does language shape the design of the application? What do you guys think about that? Eric, you want to start?
Yeah, sure. So sort of what I was talking about before, the way the paradigm of the language can kind of help the code design, that you can focus on solving the problem instead of how you need to solve those specific details. And I think the language can provide a higher order construct, so you can talk about the higher level problems. So I think one of the very good examples and kind of famous example are the pipes in Elixir. How we can usually, when we need to write nested function calls, we need to write them kind of backwards. So if you want to see the first operation, you need to kind of go and look into the nested function call. But with the pipes, we can have this listing of the functions in the order that they are performed. And I think another thing, not necessarily a language feature, but a standard library feature are the supervisors and the application structure. The supervisors not only give us the concurrence and the fault tolerance, but they also give us the structure of how we want to model the processes and the whole application with the help of the supervisor tree. And I think it's features like that that can kind of help drive that design.
Yeah, that's a great point, Eric. Ulf, what do you think? Can you
pick
up on any of that?
So Eric and I previously when we had a little warm-up discussion, we talked a little bit about the pipes, which was one of the introductions in Elixir that differs from Erlang, and how, essentially when you get a feature like that, then suddenly people start arranging their code so that they can use it. And one of the things that has not really been very disciplined, if you look at Erlang code, is where you keep the state variable. For example, in GenServer, behaviors in general, you tend to want to keep the state variable last. But of course, if you want to use pipes, you want to have it first. And then people start doing that because they love the construct so much. And I was also thinking about another thing that when in the early days of Erlang use, for example, when we started out with the AXD 301, the hardware we had to run on was actually 32 megahertz microsparks initially. So finally we got some juicier hardware, but that was sort of the initial platform. And the virtual machine at that time could only handle 32,000 concurrent processes. Now, our requirement was to serve at least 30,000 phone data calls simultaneously in the system. So obviously we could barely have even one process per call, at least running. And that led us into a lot of very convoluted designs where we had to conserve processes. So we couldn't actually run the or use the sort of the mental model that you have a process for every naturally concurrent activity. And practically, well, every single time you had to do that, that actually introduced pain, what Joe would call accidental complexity, where the language is actually forcing complexity on you that wasn't actually part of the initial problem. And we actually carried a bunch of baggage with us for a number of years. That's sort of one of the virtues or rewards of being successful in commercial programming, is that you have to live with the legacy. But when multi-core came along around, what was it, 2009, we discovered that the most performant code on Erlang multi-core was actually sort of textbook Erlang. And we discovered that we actually had to, we didn't have to change much to run our code on multi-core, but to make it fast, we had to undo a lot of the optimizations for single core that we had, overuse of ETS tables, clever, or whatever you want to call it, use of yield and things like that. All those things basically had to go. And interesting, at the same time, Hans Nilsson and I had been talking about what we thought would be kind of an ideal for programming. And you read a lot of RFCs or CCIT standard documentation in telecoms, and you read the spec and you're confused. Someone is calling me on Discord, I think. And then you try to write a prototype to see if you understand the spec. And well, once you have that working, you understand a little bit more. What you then should do is rewrite your code so that it's eminently readable, so that the next person who reads the spec and is confused then reads your code and goes, now I understand what they were trying to say. And then if that is not the best code that you can run in your production system, then you have a research problem on your hands. So we started feeding back to the OTP team, and they, of course, were quite receptive. That is the code we would like you to optimize the VM for. And I think they pretty much have done that. I mean, they reluctantly optimized it for the code we thought we had to write before that. But and I think this has been a beautiful thing. So, and I guess this is where I remember talking to Simon Peyton-Jones at around that time too. We agreed that we both liked opinionated languages. And we also agreed that Erlang is an opinionated language, the opinionated language for concurrency. And well, Haskell is the opinionated language for static typing, where if you like that kind of programming, that is the lifestyle that is kind of ideal. It's the language that takes the best care of you. Whereas the Erlang languages tend to give you sort of a warm and fuzzy feeling about concurrency, which is almost the opposite of what a lot of other language environments do, where they will publish books about, all the pain and how to navigate that when you have to do concurrency. Sasha Jurek actually said one thing when I met him in 2019 at the GoTo conference, an interview or a chat that is actually going to get published now in the GoTo unscripted sessions 2 years later, that he felt that after 10 years of Erlang programming and then moving over to Elixir, Elixir is more complex and sort of encourages more complex sequential programming. Whereas with Erlang, you could say that it's almost bare bones in terms of the sequential. I mean, it has nice features like pattern matching and mostly functional programming, but it's almost trying to be as simple as it can be. Initially, it didn't even have floats, actually, because you don't really need floats in telecoms, but I think it's an interesting evolution that sort of Elixir steps up the expressiveness in the sequential parts while keeping the concurrent model, the concurrency model, the supervision model, all that has now become sort of, well, pretty much familiar to a lot of people, and also has much broader applicability than just telecoms. And maybe that's also a reason why we're now seeing things like machine learning capabilities coming, more fancy tools, which I think there is a history there that probably Francesco and I can share war stories about over beer forever. But that when we started, like I joined Ericsson in '96, the first project I was put on was to try to see if I could find a way to use rational rows, which at that time was basically applying the Booch model, a predecessor of UML, to Erlang. And essentially I had to show that it buys an Erlang programmer absolutely nothing except extra work. And so at that time, in that culture, we almost became anti-tooling. It was like, just give us an X-term, Emacs, and get out of our hair, because none of the tools that you want us to use actually give us anything. And then that pretty much became a culture. It was like, I'm fine. I have Emacs, syntax highlighting, that's fine, that's enough. And then eventually, some information from the outside world started seeping in that, the Python guys and the others, they actually have much better tools than you. And the IDEs for Java and everything, well, granted, they can't survive without them, but boy, their tools are just absolutely amazing. And I think Elixir has sort of been a pathway to much better tooling, much better documentation, a much more modern way of working. And this indicates another thing, is like how the effect of culture on tooling and design and everything. It's sometimes you get kind of caught in a rut, even if you know that you should improve. your community has been shaped around some key tenets, and even if you know that you might want to have some better tooling or better support in some areas, there are not enough people crazy about those things in your community that you can ever garner enough, critical mass to change things. Web UX support, for example, in Erlang, it's not like that we didn't understand that it would be nice to have. It's like there were not enough crazy web UX guys in the community to change things.
Mm-hmm.
And too many sort of hardcore back-end developers who, were used to systems who didn't even have a console, or if they had, it was just basically Xterm and not much more than that. And so I think this is a beautiful thing where you can have a couple of different communities that complement each other on the same virtual machine, or in the same sort of universe, and because then you can start cross-pollinating each other.
Yeah, that's something I've heard quite a lot, is the effect that the Elixir community has had on the Erlang community. I've heard lots of people say things like that, and one of the ways that I think I've commonly heard the Elixir community has impacted Erlang is in tooling. And I'd really love to hear both of your thoughts about tooling and how that can affect design. In the talk that we're having today is about design. I know I am a user of the Elixir language server, and that has drastically changed the way I design now that I can do really easy go-to definition for functions and things like that. Both of you are both long-time developers in these languages from before there was much tooling. And I guess starting with Eric, I mean, how has tooling and the development of some of the tooling recently changed the way you design in Elixir, the way you design applications? Has there been any impact, or can you tell us more about that?
Yeah, I think first of all, I would like to say that I think that it's really a mindset thing that kind of drives the community here. If you can provide good tooling, and if you can have good documentation in say the course and the library, in the core libraries and such, I think that drives the rest of the community to do the same. So when they build libraries, they're going to have good documentation. They're going to provide good tools so that you can use those libraries. And I think for me, the important part about the tooling is that it's supposed to get out of your way. The tooling isn't there for just the tooling. It's supposed to help you focus on more important things. So for example, Elixir added the formatter a few years ago, and I think at least for me, the main benefit of the formatter wasn't really better looking code or better syntax. It was that I could just run the formatter and I could focus on something else, on something more important. And it's the same thing with mix and with hex. I mean, the goal of the package manager is that I shouldn't have to solve a problem someone else has already solved. And I think when I got into the Beam community like 7 or 8 years ago, and I looked at the Erlang community, I saw this problem that there was a lot of good libraries, but they were kind of fragmented. If there was a bug or a new feature needed in a widely used library, it was common that there was a fork, and that bug was fixed, but just in that fork, and it wasn't really contributed back to the. It wasn't contributed back to the. It wasn't contributed back to the main project, and I think something like a package manager helps with that, because there is no. Because then there is the main package for that project, and again, it's not just the package manager, it's the kind of mindset in the community that you should be a good citizen, you should be contributing back, you should contribute to documentation fixes and so on.
Well, Ulf, how has tooling changed the way you design code over your many years? I know it's been a big journey from the very beginnings of Erlang to now.
So I was thinking that, I mean, one of the obvious dramatic changes in terms of tooling that I've seen is when I joined Ericsson in '96, for example, the version control was pretty much done with CVS. Or possibly clear case, but we don't need to talk about that. And then, Subversion came along, kind of improved things. But the thing about them was that essentially, if you wanted to contribute to someone's Subversion project, you had to be sort of given the keys to their house and be allowed to camp out in their living room. It was that kind of interaction model, and then with Git and the way we can work now with just if you want to experiment with somebody's code, you just fork it, and it has just completely changed how we work with code reuse and how we work with collaboration, and it's hard to even imagine how we did it before Git, I think, nowadays, because it is just so completely different. And then, of course, tools evolve, like Eric said, with the package manager and everything that we nowadays reuse is so amazingly easy. And I think it was kind of wonderful that we got the sort of experiment with Erlang got to play out, where they started with sort of what they wanted, what was a pure conceptual model for how to just build very complex systems with the least amount of crutches possible. But that doesn't mean that it can't get infinitely better with the kind of tooling we have today. So I think And when you start building that on sort of an infrastructure that so encourages reuse, separation of concerns, and then it can get pretty amazing.
Yeah, that's a really good point. Is once the tools for collaboration are there, then it makes it so much easier to share code and to want to extract certain parts of functionality into something that can be reused, and that's a whole lot easier with Git than when you're checking out files in Subversion or something like that. It definitely changes how you think about it. And I hadn't even thought about version control as a tool that would help influence the way that we design. But that's a really, really good point. It probably has a huge, huge impact in the way we design our applications. So we are running a little low on time. We have a few more minutes, and there are a lot of good questions in the Q&A. So
I promise to try to answer all of the ones that we don't have time to answer now. I will certainly try to give my answers in the chat.
That's really kind of you, Ulf. But the first one that we're going to go to, the top voted one at the moment, is Sophie asking about anti-pattern. Sophie, if you want, you can unmute yourself and ask, or I can ask for you. It's your choice.
Yeah, sure. I'll ask my question.
There you go.
Yeah, thanks, Devin. Yeah, I'm wondering, this is kind of drawn from my own experiences coming into Elixir from Ruby and writing some really kind of messy OO inspired functional code at first, but I'm curious, are there any anti-patterns that you guys want people to avoid when building out Elixir, Erlang, or OTP apps?
Well, the mother of all anti-patterns when approaching Erlang is to try to make it object-oriented. And we've all gone there. I spent about 3 months alone in Alaska trying to make Erlang object-oriented before I gave up. So, and I would say another one is, and this is a common pattern in bigger projects, especially, is where you feel that you absolutely have to own your process. So you create processes to essentially manage your own island, so to speak. This is the way you isolate yourself from the rest of the world. The thing you want to do with Erlang and Elixir is to really think about the natural concurrency in your problem. A lot of beginners also want to weld modules and processes together, and even though it's kind of the way you do it with sort of gen servers or whatever, a process has a module that implements the API. Okay, and an anti-pattern would be not to do it that way, but you don't want to model your process model after your organization. You want to actually look at what is inherent in the problem that you're trying to solve, and then go from there. And if you can, describe it in how you would actually do it manually. The same problem. If you had to solve it with people, how would you do it? And each person would probably represent at least one process, or maybe a cluster of processes in your system. And it's a different way of thinking, but I think that's it's a very good model. And another thing that I've thought about is you don't just go crazy with adding flexibility in your code, making it impossible to test, because practically every product that has the fortune to succeed and enjoy a long life, eventually you will pretty much get bogged down by your test suite if your code has more flexibility than it needs to have. And so, I mean, these are very general things, but I can't really think of very many specific Erlang specific.
Those are great. Those are really great responses. Ulf, Eric, do you have a one or two off the top?
Yeah, I think we already touched on the most important thing, and is that processes shouldn't dictate. They should dictate the concurrency and where you want to hold state, but you shouldn't use them for a code organization on that level that you do in the object-oriented languages. And another similar thing is that we've seen in Elixir, which is similar. It is when you try to use macros and code injection to get the code reuse. It's very easy to try to build this huge macro that can inject the common code, but that's really not advised. And instead, you should use the tools that were already there from the beginning before macros, like behaviors, and just higher level functions, and use that for code reuse.
Also great advice. Yeah, I can second all of that. Those are all great pieces of advice. I mean, if we can do it really quick, there's one more question I think is really interesting from Brujo. Brujo, if you want to unmute yourself, you can ask.
Yep. Yeah, you can hear me?
Yeah.
Yeah, cool. So I've been an Erlang developer for a couple of years, and I haven't had the chance to read Ulf's code multiple times. And
For you.
yeah, that's exactly the question. So basically, you were talking before about how to make the code readable for future developers and whatnot. And part of my experience is that in my very first years, I was not really able to understand your code. But after a couple of years working on Erlang myself, that was the right way to do it. I would have written the same code. So the
Holy
question
cow.
so
Okay.
the question is, how do you think this affects the developers, and how do you tackle this situation where you have new developers coming to old code?
Oh, so my personal view of my code is that it suffers from the fact that I very seldomly, or at least for a long time at Ericsson, I wasn't actually in a role where I was supposed to be coding, but I ended up having some coding tasks on the side. So I had to code opportunistically. It's like, oh, no one is knocking at my door right now. Let's just type, turn out some code. And I thought my code was pretty much terrible for it. But on the upside, the problems I usually tackled were things where I thought that there was something structurally missing in how things, GPROC came out of an analysis like that, where, structurally it actually beautifies other people's code. I don't know if that code in itself is the best one, but I think there is an opportunity with Erlang and Elixir that you can actually write very simple code. And I think one of the benefits of Erlang, at least we thought so at Ericsson, was that you could actually take pretty crappy programmers and they could write code that was usable in production. Contrasted with, for example, C++, where you really didn't want any other programmers than experts touching production code if you could help it. But with Erlang, you could actually take someone who more or less sucked at programming, and they could still, if they knew the domain, produce something that mostly worked. I don't know. I don't really know what to say there, but I think really trying to make sure that other people read your code and is very important, because ultimately, what do they say? Like 15% of the effort is writing the code, 85% is maintaining it, and that's usually not done by you. And I guess that was also the case for me, that I had to try to quickly write code that somebody else would be using, or, well, if they found it valuable. So I don't know.
Great. Well, I think we're a little bit over time, and I think we're going to have to call it. Eric, I mean, if you want to, if you have a couple minutes, then, or a couple.
Yeah, I can just say quickly, and it's sort of the same thing that you were already talking about, and that is to not try to get too fancy with the code. Usually, if you try to write very short code, it usually becomes more complex. It's easier it's better to not try to be too clever. Makes it easier it makes for easier readability. Just to sum it up.
Yeah, that's a great point. Exactly. Well, thank you both for your time and for coming to chat today, and your knowledge and your experience and all of that, and sharing that with us. I think we had a great conversation, and I just want to say thank you for everybody, and for all of the participants. We're going to have a little break, and Remember, if you want to, you can rate this on Wova, rate this session. Of course, constructive feedback is helpful, but don't be mean, just be nice, and whatever constructive information you have, that would be great. Thank you again, Eric. Thank you, Ulf. And I guess we will talk to everybody later. See you all in the next sessions.